All right, hi everybody. This is the Math 31 derivatives review. This is question 15a. Okay, I'm going to address the zoom on this here because we're going to graph the first and second derivatives of this function here. Okay, now this is all about just understanding how derivatives work here. Take a look at this graph here. The first derivative, okay, remember what the first derivative is. It's the slope of the tangent line. So I'm going to just zero in on a few things that I know are true. I know that the slope of the tangent line right here is 0. So that means my derivative is going to go through 0 right there. The slope of the tangent line right here is 0. So I know my derivative is going to go through 0 right there. So I'm going to make nice big points there. That's where my function is going to go here. Now, these are all the tangent lines along every point along this section of the line down to here. These are all negative. The tangent line up here is got a really steep line. This is a very large negative. Down here the slopes are quite shallow. They're getting closer to 0. These are getting smaller. So these are all going to come down here. Then what's going to happen here is my slopes, the tangent lines between these two values are going to be positive. They're going to be 0, a little bit positive, they're going to get bigger. They're going to hit a maximum somewhere around the center here. Now, I don't know what the slope is. I have no idea. Let's just say that the slope is somewhere up here is my maximum. It's getting the exact value is not the issue. The issue is getting the trend here. So then what happens is I've got positive slopes that increase to a maximum, and then the lines start to drop down again until the slope is 0. And then they're negative, small negatives getting larger and larger and larger. So really, what's going on here is this thing is doing that. Okay? Actually, that's a pretty good parabola. Anyway, and that's what I would expect. We've already talked about what happens with the degree. This is looking like a cubic. I would expect the derivative of a cubic would end up being a quadratic, a parabola. Now let's take the derivative of the parabola. Well, notice that it's going to equal 0. The slope of the tangent line to the parabola is going to go to 0 right here. So my second derivative is going to go to 0 roughly about right here. All of the slopes to the left of that point, all of these slopes are negative. I'm sorry, positive. All these slopes are positive. Now, just slightly to the left of it, these are small positives that get larger and larger and larger. Just to the right, the tangent line has got a small negative slope, small negative slope, and then the number's getting larger and larger and larger as you go further down because the line's getting steeper. So really what happens here is we've got this straight line, and there's the second derivative. And again, that makes perfect sense here because when we drop the degree by taking the derivative, a quadratic should turn into a linear. Anyway, those are the two graphs, roughly.